So here we were studying about the correlator. So we can say the correlator is coherent baseband receiver system. While detecting a signal at the receiver end, we can use the circuit. That circuit is called as a correlator, which is used as a combination of multiplier and a integrator. So you can see, you can observe here the figure 3.12, in which you can see the coherent system or a correlator of the baseband signal reception. So here the received signal along with noise, you can see when we are giving the input signal, there is a presence of noise. So here we can say the received signal along with noise is multiplied by locally generated signal. So here you are giving input to the multiplier and it will be multiplied with locally generated signal. And located generated signal we are taking as S1 of t minus S0 of t. So here the output of multiplier we are giving to integrator. If you see, we are giving these to a integrator, and the multiplier and integrator we are saying as a correlator, and the output of integrator we are giving to the low pass filter, whose response it samples at t equal to ts seconds. So immediately after its sampling, the energy storing element of integrator is discharged, and the output signal and noise are we will get as S naught of ts equal to 1 upon 2 integration 0 to ts si of t s1 of t minus s naught of t dt. So here we can say when we are giving the input to the correlator, at that time we are supposed to give that input to the multiplier, and multiplier will multiply that input signal with the locally generated signal, and the output of the multiplier is then passed through the low pass filter integrator, whose response is sampled at time t equal to ts seconds. So after each sampling you will get the energy storing element of integrator, that is nothing but you will get as the output signal and noise are as in relation, like S naught of ts equal to 1 upon 2 integration 0 to ts si of t s1 of t minus s naught of t. This is the local signal in of dt. So here you can see you will get the output, that is nothing but v naught of t. So here we can say you will get the output signal like this. Now we can see about the noise signal. So you will get the noise signal, that is n naught of ts equal to 1 upon 2 integration 0 to ts n of t in bracket s1 of t minus s naught of t dt. वहाँ पे लिया था हमने input si of t, here we will take the noise n of t. So here you will get where we are taking si of t equal to s1 of t, and yes o of t equal to we are taking as a s naught of t. So we can say where we can take si of t that will be equal to s1 of t or the s0 of t. So here we can say from the equation of output signal and the noise signal, at the output of the correlator receiver circuit, the signal part will dominate the noise as because the product modulator performs for all possible input and it will chooses the best out of them. So here the signal part will result in the maximum correlation, therefore the SNR will be higher. You will get here higher value of the SNR. So here you can see the comparison between the correlator and matched filter. We have already seen about the matched filter. That is nothing but the optimum filter with the zero mean. So here we are saying that noise is additive Gaussian white noise. At that time we are saying that optimum filter as a matched filter. So here we are supposed to see about how we can compare correlator with the matched filter. if we are replacing the correlator by the match filter, how we will give? We can give the received signal. That is, you can take R of t equal to Si of t plus noise N of t. We can give that received signal to the match filter. You will get the sample at t equal to Ts. So, if you are taking h of t as the impulse response of the match filter, what will be the output of the match filter? You will get output equal to g of t equal to h of t complex star into R of t. So, here you can write g of t equal to integration minus infinite to infinite R of lambda h of t minus lambda of d lambda. So, here we can say if we are taking the match impulse response for input signal S1 of t and S2 of t, what equation you will get? We have seen this already. What you will get? You will get the output of match filter will has two parts. These are nothing but output signal and the noise. So, you will get output signal S0 of t. How you will get for the match filter? You are supposed to compare these equations of the correlator with the match filter. So, here you will getting S0 of t is equal to 1 upon 2 integration 0 to t Si of t S1 of t minus S0 of t dt. But for match filter, you will get S0 of t equal to 2k upon N0 integration 0 to Ts Si of t S1 of t minus, if we are taking S1 and S0, you will get S1 of t minus S0 of t dt, and you will get there the noise signal, that is N0 of t. How you will get? N0 of t is equal to 2k upon N0 integration 0 to Ts N of t S1 of t minus S0 of t dt. So, here we can say if we are comparing these equations, we will conclude that output of correlator and output of match filter are identical. We are getting the same equations. There also we are getting the signal output of the match filter in the two forms. These are nothing but you will get output signal and the noise. And equations, if you compare for the match filter and correlator, we will get the same equations. So, we can say if we are using the correlator instead of match filter, at that time also we will get the same output. So, here we can say the performance of the two systems, these are nothing but the correlator and the match filter are same. These are correlated because they are giving the same performance. So, if we have to synthesize a filter for minimizing the error probability of receiver optimum filter, we can either use match filter or we can use correlator, because both are having the same output and both are having the same performance. So, we can say if we are supposed to synthesize a filter for minimizing the error probability of the receiver optimum filter, we can use match filter or we can use correlator. And the mathematical operation of match filter is convolution, whereas correlator output is nothing but correlation. So, if we are saying the mathematical operation of match filter is convolutions, and in correlations, correlator output will get the correlations, but they are behaving in the same way. They are having the same performance, they are having the same output, identical output. So, we can say the impulse response of the match filter is input signal reversed in time, and convolutions also reverse in time. So, we can say that process as nothing but a correlation. So, here you can see, observe here the waveform when we are comparing correlator and the match filter. You can see we are giving the transmitted signal to the match filter and the correlator. At that time you will get the output for the match filter and how we will get for the correlator. So, here we can say the impulse response of the match filter is input signal that will reverse in a time, and convolution also reverse the signal in time. So we can say that process as nothing but a correlation. And if you see, the correlator output and match filter output are same, only you can see here where we will get the same output only when t equal to ts. If we are taking t equal to exactly ts, you can see we are having the same output for match filter as well as for the correlator. So we can say if we are giving the sine wave input to the correlator, we will get correlator output is linear ramp. You can see the second one diagram. If you are giving like a sinusoidal waveform, you will get there the ramp, whereas match if we are giving the sine wave input to the correlator and to the match filter, correlator output is nothing but the linear ramp, whereas match filter output is amplitude modulated linear ramp. You can see that in second row you are getting at the output of match filter, you will get amplitude modulated linear ramp signal, and here in the correlator you will get the output that is nothing but the linear ramp. So we can say both correlator and match filter are having the same performance. Output of correlator and match filter are identical, and impulse response of the match filter is signal reverse in time, and convolutions will also reverses in time. So we are saying that process as nothing but a correlations, and the correlator output and the match filter output, they are same only when t equal to ts. If we are calculating the probability error for correlator, like we have seen the probability of error for the match filter, we have seen for the optimum filter, like that. If we are calculating the error probability using the signal space and decision theory, how we are taking from the signal theory? We are saying from the decision theory, if we are applying minimum error test, we know minimum error probability we can take as. How we are taking? We are taking probability error. If we are taking two signals, S01 of t, S02 of t, how we will get? You will get probability of error P of E equal to Q into S01 t minus S02 t upon 2 sigma naught. So here we are saying sigma is nothing but variance sigma naught square. We are taking that as a n naught by 2. So here if you solve these equations, you will get error probability equation will become P of E equal to Q into square root of E upon 2 n naught. So here we have seen about the coherent, which will have the same performance with the match filter. So we can say when we are using the correlator, at that time it will work exactly in the same performance. It will have same output as compared to the match filter. So we can use either a correlator receiver circuit, or we can use a match filter. And what we have seen about practically how we are using the coherent circuit, if we are supposed to use correlator receiver, we are supposed to use multiplier and a integrator. Because when we will give the transmitted signal as an input to the receiver, at that time it will give that to the multiplier, and it will multiply that input signal with the locally generated signal, and again that output will go to low pass filter integrator. So you will get the output at the sample version. Here we have seen how we can use correlator. So here we can say, we can use here either a correlator, or we can use here either a correlator or match filter. So here we have seen about the how we can use correlator instead of match filter, because as we are saying a correlator, it will have the similarity. It will give the same performance if we will compare it with the match filter. And correlator is the receiving system which is used for the coherent reception of the binary digital modulated signal. So here we are giving the received signal as an input to the multiplier, which will multiply that signal with the locally generated signal, and received signal will either we can take if we are giving the two signals. You can see here we are taking either we are giving S0 of t or either we are giving S1 of t. So received signal either will be S1 of t or the S0 of t, and it will along with the noise. And again we can give the output of multiplier where we will get noise as well as S1 of t or S2 of t. That we can give the output of multiplier we can give to the low pass filter integrator. So here we can say the output of multiplier is passed through the integrator whose output is sampled at t equal to Ts, and if you see you will get the output signal that will be in the form of output and noise. Output if you compare for the correlator and the match filter, you will get the same equations for the correlator and the match filter. So we can say the output of the correlator signal part will dominate the noise, as because product modulator performs for all possible input and it will chooses best of them. So the signal part will result in the maximum correlation. So here if we are using the correlator, you will get improved SNR. So we can say if we are using the correlator receiver circuit, the product modulator performs all possible inputs and it will chooses the best out of them. So here the signal part will result in a maximum correlations that will give us higher SNR value. So here we have seen about the correlator. Remaining we will see in the next class. Thank you.